Hello. In the last session, we have studied about different types of amplifiers and classified the amplifiers as class A, class B, class AB, and class C amplifiers. Today, we are going to study class A amplifier in detail. What is a class A amplifier? Basically, a class A amplifier is a common emitter power amplifier. So it is a common emitter power amplifier. Then we can say that it is a direct coupled amplifier, which means the load RL is connected directly to the collector. So it's a direct coupled amplifier. Then what is other speciality? It is an audio frequency amplifier, which means usually class A amplifiers are used for the amplification of audio frequency signals, which means it can amplify or it usually amplifies signals in the frequency range 20 hertz to 20 kilohertz. So these are the common features of a class A amplifiers. What is the difference between a small signal common emitter amplifier and a class A amplifier? Well, the first difference is the amount of voltage, the value of voltage and current handled by the amplifier. In the case of a small signal amplifier, the current, the input current, which is the AC signal current, is in the order of some microamperes, and the voltage may be a few millivolt. But in the case of a class A power amplifier, the current it handles is in the order of milliamperes and the voltage is a few volt. That's the first difference between a small signal common emitter amplifier and class A power amplifier. Then the second difference is associated with the first difference. Since we need to amplify larger signals, we need to handle large power. For that purpose, power transistors are used in the case of class A power amplifier. So these are the differences between a class A power amplifier and a usual small signal common emitter amplifier. Anyway, a class A amplifier is a common emitter amplifier. So we may define a class A amplifier as a transistor biasing in which the amplitude of the input signal is maintained in such a way that the output current flows for the complete cycle or 360-degree of the input signal. This means you are always getting an output whenever you have an input signal. You will get an output signal always or throughout the time when you have the input signal. So all portion of the input signal is being amplified at the, and you are getting it at the output as an enlarged version. So that is the definition of a class A amplifier. But how is it established? Well, the trick lies in selecting the Q point or the quiescent point of the operation of the transistor. We have studied about this quiescent point earlier. The quiescent point is made at the center of the load line. How this is made? This is made by the proper selection of the resistors which are used for biasing the transistor. By adjusting the values of this R1, R2 and RE, we will make sure that the transistor is operating at the quiescent point, which is exactly at the center of the load line. So this figure shows the variation of the collector current and the voltage, the VCE, the collector emitter voltage. When the input signal comes in, the base current changes and the collector current changes in accordance. When the base current comes in, the collector current increases and it reaches a maximum value which is 2 times ICQ, where ICQ is the collector current which is corresponding to the quiescent point. Then when it can go below up to 0 collector current. Likewise, when the collector current increases, the voltage at the collector decreases. So VCE decreases. VCE decreases to a minimum value of 0, and then thereafter it can increase. When the collector current decreases, the VCE value increases, and it can reach a maximum value of 2 times VCEQ, where VCEQ is the voltage corresponding to the quiescent point, which means the collector current can vary between the cutoff value, that is 0, and the saturation value 2 ICQ. And the collector emitter voltage VC can vary between a 0 value and a maximum value which is 2 VCEQ. So we may say that the peak value of collector current is ICQ. Why? This is the swing of the collector current, and this comes to be ICQ. The magnitude of this is ICQ, and this is also ICQ. So this is the peak value of the collector current, and similarly the peak value of the collector emitter voltage is VCEQ. VCEQ. So this is the analysis of the AC load line of a class A amplifier.